Now let's discuss Coulomb's law in electrostatics. Coulomb's law deals with interaction between two charges. What it says, if there are two charges Q1 and Q2 having a separation of R, then force on Q2 by Q1 F is proportional to Q1 is proportional to Q2 and is inversely proportional to square of separation between the charges. Because of 1 upon R square, it is also called inverse square law. When you group all three things, it becomes F proportional to Q1, Q2 upon R square. When we remove proportionality sign, we use a constant, and that constant is K, and force becomes K Q1 Q2 upon R square. K, it is 1 upon 4 pi epsilon 0. Its value is 9 into 10 to the power 9. We'll discuss epsilon 0 later on. For the time being, when charges are placed in vacuum, K is given by 9 into 10 to the power 9. The important thing is, this F is force on Q2 by Q1. And from Newton's third law, we know that for every action there is an equal and opposite reaction. And therefore, Q2 also exerts the same force on Q1 in the opposite direction. This F and this F, their magnitudes are same and they are acting in the opposite directions. Well, I am assuming that both charges are of same polarity, and therefore I have shown repulsion. This force is given by K Q1 Q2 upon R square. Now the most important thing, suppose we have two rods having charges Q1 and Q2, and separation between the rods is R. In this case, we cannot use Coulomb's law in this form. Why? Because these are called line charges, and Coulomb's law in this form is valid only when both Q1 as well as Q2 are point charges. So remember, if you are dealing with charges other than point charges, do not use K Q1 Q2 upon R square. We can find force between the rods with the help of Coulomb's law itself. हमें करना क्या होगा, इन rods को points में break करना होगा, and then we'll use integration and we can find the force between the rods, which we'll see later on. For the time being, Coulomb's law in magnitude form is given by K Q1 Q2 upon R square.